There are three operating steps for the RSL membrane. 1. Filling the housing with treated water and adding the ionic powder to the surface of the membrane. RSL membranes rely on an ionic powder to simulate a highly ionic localized environment on the surface of the membrane and a contained housing full of water. The ionic powder is applied at the beginning of each filtration cycle. 2. Undertake the filtration of the water. A filtration cycle will last 2 to 30 hours depending on the raw water quality. The ionic powder creates a 100 micron powder skin layer on the outside surface of a membrane tube. The membrane tube has pore sizes of 3 to 5 microns. As the filtration of water continues, the TMP increases. 3. Undertake a backwash. Once the pressure across the membrane, TMP, reaches 70 kilopascals or 10 pounds per square inch, the ionic powder skin layer is backwashed from the membrane tube. The contents of the membrane housing are also removed to a sludge tank. Step 1 is then repeated. The housing is filled with water and a new ionic powder is placed on the membrane tubes. The replaceable skin layer, or RSL, was the premise behind naming of RSL membranes. During the filtration cycle, water-carrying colloids, which have their own electric double layer or EDL, approach the surface of the membrane tube with the ionic powder skin layer. The replaceable skin layer, RSL membranes, do not rely on the development of a filter cake on the surface of the membrane to create a barrier for colloid separation. Instead, the intense competing EDL environment from the RSL powder layer and the colloidal solids causes the water to pass through the membrane and the colloids to repel away from the membrane surface. The ionic environment from the powder significantly enhances the hydrophilicity of RSL membranes. The hydrophilicity is so intense that RSL membranes use a membrane pore size that is 250,000 times larger than the pore size of conventional UF membranes. This vast pore area difference facilitates the high flux rates at low pressure. Eventually, some colloids will enter the RSL powder layer. The electric double layer will collapse and the colloids will attach to the powder, causing the RSL powder to clog and the pressure across the membrane to increase at a rapid rate.